Next we have is routing. In the previous video, we talked about different HTTP methods and how they are important in the HTTP semantic. So in a way, all these HTTP methods, they describe your intent, which we already talked about. And you can say these HTTP methods, they express the what of a request. Your intent, your action, what do you want to do on that particular resource, or what do you want to tell your server that your intention is, whether you want to fetch some data or add some data or update some data or delete some data. And the role of routing is it expresses the where of a request. Where do you want to send your intention? Where or which resource you want to perform your action or your intent on. You need to tell the server where do you want to go. For example, you have a request and the method is get, right? Your intention is fetching or getting some data from the server, and your route path or the URL path is /users, and the server sends you an array of users. Okay. So what you're saying is, I want to fetch some data. You want to fetch some data. Your action is fetching, and from where or what kind of data, right? This is the resource. This is the route, whatever you want to call it. And the combination of these two, your intention, your action, and your route, the URL parameters, the address, the server takes this and maps it to a particular handler or a set of instructions, and it performs all the business logic, the database operations and whatever is needed, and returns you the data. And to summarize it, you can say that routing is basically mapping URL parameters to a server-side logic, and that's all there is to it. And here we have our familiar Burp Suite interface, and we have a React app which we will use to demonstrate some of these routing concepts. So I'll just go ahead and fire some APIs, and then we can jump in and do some analysis. So the first request was a GET request. And if we look at the request and response, this part we are already familiar with. This is the HTTP method. This is our intent or the action we want to perform, which is get or fetching. Now this part, this is what we call the route, right? The address of our request. Where do you want to go in the server, which is in this case /API/books. Books is called a resource, and we'll learn more about resource when we study about REST API concepts. For now, we can just assume this is a route, right? And this is a route. So this is our action. This is the address we want to go to in the server. And when we send this request and the request goes through, the server responds with this data, right? Whatever the response is. It does not matter, and for the sake of this demo, we are just sending some fillers. But typically, this is what happens. You send a request, the server does some kind of authentication. If it's there, then it sends the data. And then in the next request, which is a post request, here the intention is post, the HTTP method is post. The route is still the same, /API/books. The request goes through, it creates another book or whatever the resource is, and it returns all the resources again in the response, right? So if you notice here, in the previous request and in this request, this route part is the same. So what happened is, in the previous request, the request was a get method and the route was /API/books. And in this request, it's a post method, right? And the route is still the same, /API/books. So what happens in the server is these two things, the method and the route, these two things are kind of a key which map to a particular handler in the server, right? The server first checks what the method is, then it checks the route, and it concatenates these two and forms a unique routing logic, right? This is a unique path and this is another unique path. These two will never clash, right? These methods, they differentiate between the two routes. And now that we know what basic routing is, we can jump into different types of routing, right? And the first two examples that we discussed, the /API/books for get and post, these kind of routing or routes are called static routes, right? And why are they called static routes? For obvious reasons, because they don't have any variable parameters inside the route. And what do I mean by variable? For example, this part /API/books, this will stay consistent this is a constant, right? We don't have to think about a dynamic parameter inside this route. This is constant. We are always going to use this string /API/books whenever we make the request. Nothing changes in that. And it is always going to return this kind of response. That's why it's called a static route. It's a constant, or it's a particular string which never changes, and it always returns the same kind of data. So in that case, what is a dynamic route? So let's fire these two requests now. And if we look at the first one, so here if you see, the method is get and the route is /API/users/123. And in this case, this is supposed to express the ID of the user. The application of this API endpoint is we can fetch details of a one particular user using the ID of the user inside the route parameter. And when we make this request, the server can extract this particular ID from the route path, and it can do whatever operation it wants to do, like fetching the user from the database and returning the details of the user. In this case, the server is just fetching the user ID and returning it in the response to express that it got the user ID from the route. Since in this video, we are not going to get too much into the code, and we just want to understand the concepts behind it. But just to give you an idea, this is what the route matching part in the server looks like. The server is basically saying, let's say the handler is called route, or let's say it's called R, right? R dot get, and in the matching part it is saying it's a string /API/users/:ID. This part matches the method in the server, and this part matches the route. So the server is saying if any request with the method get and with the route /API/users, and in the next part any kind of string, right? This :ID, it basically means any kind of string that comes in this format routed to this handler, whatever handler is waiting to respond to that kind of route, right? So the thing to remember is this convention you'll find in any kind of service. It does not matter it's Java or Python or Node.js or Golang, Rust. It does not matter. This is just a convention you'll find. This is what I've seen the industry-wide practices, mostly colon, which says it's a dynamic parameter that the user is going to send in place of ID. The use of this is when the request comes, in our case, the request was /API/users and /123. The request got routed to this part. It matched with the get, right? We were sending a get request. And in the next part, it matched the first /API, then the next one /users. And it's a string, right? It looks like a number, but in route parameters or in route paths, whatever number, special characters, everything is converted into a string. So this gets inserted into this slot, this dynamic parameter slot, which we are calling as ID. If you read it, it's clearly readable, right? You can read it. Like you're saying, fetch me some data because it's get. And where is that data? That is in /API/users. And whose data that is? It is of the user with ID 123, right? It's clearly readable. That's the whole idea of REST APIs, because it provides a human readable construct to routing. This is called a dynamic route. And the terminology that we use is this part is called a route parameter or path parameter. That is something to remember. We have like two different types of parameters. That's a little confusing. One is these kinds of parameters. These kinds of dynamic parameters are called path parameters because they go right after the /, right? It is part of the route. That's why they are called path parameters or route parameters. And the next one we have query param. So for this, we can just type out something. Let's say some value, and let's hit this API. And if we look into this API, this is what it looks like. This is the method and this is the route, right? This whole part is the route. Basically, the route is /API/search (query equals to sum plus value. And now I realize this is more readable here than here. But anyway, we'll make do. So this part we understand, right? This is the route /API/search. This is the address that we want to go into the server. This is the part that server uses to match, including the method, and this route, this is the part the server uses to match it to some handler, and it performs the logic and returns some data, which is not important. The thing to focus here is the query part here, the question mark and the key and the value. This is called query parameter. That's the terminology. And next is the application. Why do you use it? Because in post requests or in put requests, we have the body of the request, right? We get to use the body, and we can use the body to send some kind of data, send parameters that we want to attach into the request. We have some kind of container to send some user defined values into the server. But in case of GET requests, in REST APIs, GET requests don't have a body. If you want to send some value in the GET request, so let's say you can say that we can send those values in the path parameters, right? But path parameters serve a particular purpose, right? They serve as a semantic expression, right? In the previous request that we saw, we were saying /API/users/123. And the semantic meaning here is we want to fetch the details of a user whose ID is 123. That is the semantic expression in the path parameter. But if we want to say, we want to call this API, which is /API/search, and we want to say the search value is some random value that the user has typed into the input box. How do you want to send it? Let's suppose we want to send it in the path parameter. What will it look like? /API/search and / the value. In this case, it will be some value. Technically, it's possible. You can do this, but it's very hard to maintain, and it defeats the whole purpose of REST APIs, right? Providing semantic expressions to API endpoints. It defeats the whole purpose. That's why we have this concept called query parameters. In query parameters, we can send a set of key value pairs in a request. Typically, we use it with GET request because we don't have a body to send data in. So in GET request, we get this thing called query parameters, which are key value pairs that we can send to the server to send some kind of metadata about the request. For example, let's say it's a request about fetching paginated data. We want to fetch a list of books which are paginated. We have not gotten into pagination yet, but I'm pretty sure you must have encountered it at some point. They basically look like this. So let's say it's a endpoint which fetches a list of books in paginated format. So it looks something like this, /API/books. And when you hit it, the server returns an object or a JSON. And inside data, you have whatever a list of an array of books, and it returns a set of metadata about the response, right? And it looks something like this, like total, current page, and total pages, things like this. It depends on the implementation, but something like this. So the purpose of this is, and you also have a limit here. Purpose of this is the server will paginate the data, the response, and it will send a chunk of data. Let's say the limit is 20. There's some kind of default limit. So what the server will do is it will send 20 books from the start, and it will let you know how many books are there in total. Let's say 100 books, and what is the current page, which is the page 1, and what are the total pages. And if you divide 100 by 20, it will be like 5 pages, right? These are all the kinds of values you'll receive from the server, and the client can use these parameters, use this response metadata to make the subsequent requests according to the client's needs. How can it fetch the next page? In the next page, it can do /API/books, and in the query parameter, it can do page equals to 2, right? Because by default, the server sent the page 1. We did not have to send any query parameter for the value of page or limit. But in the second request, we want to tell the server that we want the response for page 2. So in a GET request, we can send that information using query parameters. This is one application. Usually APIs send different kinds of parameters in the query. For example, you want to filter by some user defined parameter, you want to sort it, what is the order you want to sort in, whether it is ascending or descending. All these kinds of information will go inside query parameters in the form of key value. So that is basically the uses and the definition of query parameters, and this is what the API typically looks like. Next we have is nested route. This is not really a type of routing, it's just a practice that you will see everywhere, because in REST APIs, for a semantic expression, we often have to resort to nesting, right? Nesting different types of resources, and the nested route is typically the result of that. And if we hit this API and want to see what it looks like, this is what the request and response looks like, right? So what it says is the get request, and this is the route. We can say this is the static part of the route, and this is one dynamic route parameter or path parameter, and this is the second dynamic path parameter. And the application of this is, and why do we do this? Because again, to express the semantic meaning. So what we are saying here is we want to do a get operation on this route, right? Let's say /API/users with the user whose ID is 123. You want to fetch the details of this user. So semantically, the first part expresses that we are fetching information or data which is related to this user. And the second part says we are again fetching the posts of that user. And to go one level deep again, we are fetching a particular post, which is the post with ID 456. We can stop at different phases here. Okay, let's see. So the first part, the static part, is /API/users. This is the static part. And this in itself is one route which we saw earlier. It returns a result, right? If we do /API/users, it will return list of all users, because that's the handler of that match is doing, right? If we go one level deep again, /API/users/123, and this is a unique route in itself because we added a dynamic parameter, and in the server side, it will see the get method and it will match with a different handler, right? And that handler will return the information of this user whose ID is 123. So this is one level of nesting. We can go further, which is /API/users/123 and /posts. And now at this point, what the server will see is it's a get method, and it will match with a handler which returns all posts of a particular user, because we stopped here, right? And this expresses a different meaning altogether. We are fetching the posts of a user with ID 123, all the users posts, right? And in this demo, what we are doing is /API/users/123/posts/456. And what this is saying, we want to fetch data of user with ID 123. What do we want to fetch? We want to fetch the posts, and not all posts. We want to fetch a particular post with the ID 456. So for obvious reasons, this is called a nested route, right? Because we nest different types of information in different levels to express different semantic meanings, and it results in different kinds of responses, right? That's all there is to it in nested routing. It's pretty convenient, and you will see it getting used pretty much everywhere if the API even has a medium level of complexity. Next up, we have an interesting concept called route versioning and deprecation. So let's just fire these two APIs and we'll jump into the concept of that. Okay. So if you look into this, so this looks pretty much like our earlier request, except it has this keyword, which is v1. It says API/v1/products. And if you look at the second request, it says v2, right? So this is called route versioning, which is a very common practice in API endpoints, servers, which has a REST API interface. And the use of this is, if we look at these two requests and responses for that, we'll understand why do we use versioning in servers, right? In API endpoints. If we look at the response of this, We are saying slash API slash v1 products, and this is what the response looks like. It has field data and it has an array, and each array has an object, a JSON with ID, name, price, ID, name, price, right? And in the second request, which is the v2 request, we have again data and we have ID, title, price, right? In the first one, we had ID, name, price. In the second one, we have ID, title, price. And now it is a pretty trivial example. Usually the use of versioning is, let's say you have an API endpoint and you are returning data in a particular format, right? And later on, new requirements came in. Let's say you were earlier serving a web app, and in the future, you are serving a React Native app, right? An Android app or a Flutter app. For that entity or that device, you had to change the response of your data. So your first option is changing the whole route, right? Changing the whole route matching part. So let's say you can say slash API slash new products, right? Or what you can do is you can add that to your versioning. You can say in the version 1 of our API, we were serving responses in this format and new requirements came in. And in version 2, we are serving in this format. One thing, it expresses your intention very clearly. You have the version 1 of response, your version 1 of response, and you have version 2 of response. The second part is you did not have to change your whole route. You did not have to do slash API slash new products. Using this versioning concept, you can eventually deprecate v1. You can, let's say, send a notice to your front-end engineers that after the v2 is released, v1 is deprecated. So in the next release, all the engineers can eventually migrate to v2. So they have this window, a particular window, where they have the opportunity to migrate the request endpoints to the v2 format, and eventually you will completely get rid of v1 and you will make the v2 to v1, right? So you have a very stable and complete workflow to add new structure to your API endpoints, add breaking changes to your API endpoints using this workflow. And your engineers, your client have a window where they have the opportunity to migrate into the new structure. That's the use of route versioning and deprecation. In the end, we have something called catch-all route. So if we hit this, and if we look at the request and response, so what we are doing here is we are sending requests to a route which the server does not serve for, right? We are doing slash API slash v3 slash products. At this point, the server does not serve responses for this route, right? It does not have a handler. It does not cater to requests coming into this endpoint. So typically what the server will do is, in the end, after serving all the different routes and all the methods associated with those routes, in the end, it will do is slash star. Whatever request, after going through all the previous route matching algorithms, whatever request reaches here, this part, it will be mapped to a handler, and that handler will send a user-friendly message that this route which you are requesting, this route does not exist, right? This route not found. So instead of just sending a null response, which is the default behavior if you don't do a catch-all handling, we are just sending a user-friendly message to let the client know that we don't cater to this endpoint. That's all catch-all route is about. And with that, we have covered pretty much all the concepts that one needs to know before diving deep into different kinds of routing and all the components of routing like query parameters, path parameters, and all the nested dynamic parameters. And that's all pretty much you need to know to get into a backend code base and understand the routing parts and make changes to it and add new things.